Dear ladies and gentlemen, dear Franklin, I note with great pleasure nuclear energy is back on the political stage in Switzerland. If you open the newspapers these days, you will find countless articles about the developments of nuclear energy in Switzerland and abroad. Last week, French President Emmanuel Macron announced in a marvelous speech the renaissance of nuclear energy in France, and he even outlined a detailed plan for, believe it or not, 14 new reactors in France. Why? Because nuclear energy is an indispensable pillar for a decarbonized economy in Europe. The French president delivered already last October an inspiring speech when he identified nuclear energy and entrepreneurship as crucial factors for Europe's common energy future. This, ladies and gentlemen, is also the topic of tonight's presentation. The Geneva-based startup Transmutex is working on a new and sustainable reactor design. The company was already portrayed in some newspapers, and that's probably one of the reasons for the huge audience tonight. CEO and founder Servan Schreiber will present his plans for a new reactor technology in Switzerland. He will also focus on the issue of how to use existing nuclear waste for further energy production. Mr. Servan Schreiber received a bachelor's degree in engineering and a master's in comparative history at Carnegie Mellon University in the United States. He has worked in publishing in New York, in philanthropy in Tokyo, and in a major sports organization in Lausanne. He founded furthermore a startup in Paris, and he volunteered for the environment in Geneva. In short, Franklin seems to be a very cosmopolitan person. One last point before we start. If you have questions, please write them into the chat. Franklin is happy to answer them after the lecture. And now, Franklin, the floor is yours. Thank you very much for joining us tonight. Thank you.
Good evening. Thank you very much for being here. Thank you, President Hans Ulrich Bigler, for inviting us and the Swiss Nuclear Forum. I'm Servan Schreiber, the co-founder of Transmutex, and many people have asked, how do you mix entrepreneurship and nuclear, which doesn't seem natural. But tonight, we are going to discuss how we need to take responsibility for our environment at our level and that everyone can make a difference. Nuclear energy is versatile, baseload, carbon-free energy. Many people believe that nuclear energy produces CO2. 70% of the French people believe because they see the smoke coming out of the big chimneys. But it is one of the most low carbon energy we can find here. So for that, it has saved many CO2 emissions in the last 50 years. But it produces toxic waste. And that toxic waste is accumulating at alarming speed. Here you can see a swimming pool where the waste has to remain for a number of years to cool down before it is stored somewhere. And it lasts for a very, very long time. Some of the waste lasts 300,000 years. 300,000 years is unimaginable for a common human being. It's basically Neanderthal time. We couldn't speak to those people back then. The Lascaux cave is 40,000 years. So that creates this conundrum, the problem of this beautiful energy that creates this very long-lasting toxic waste. The default plan has been to take the waste, which is not so much, but still quite toxic, and to bury it deep underground. And that makes for those huge tunnels. And it's actually quite safe on paper to bury that waste. The issue is that it's very precious real estate to bury so deep down in the earth and to make it secure for hundreds of thousands of years. In America, they did this in Yucca Mountain, in the Nevada desert. They had started to dig, and they spent $19 billion before they realized the geological surveys were not done right. But even if the hole had been finalized in the 90s, it would not be sufficient. It would have been filled already by 2015. And what happens with the rest of the waste, as you can see here on the slide, 2,000 tons a year accumulating. In volume, not so much, but still quite radiotoxic. Today, as President Bigler said, there is a renaissance of nuclear because it is such a powerful energy. In fact, the energy of the universe is nuclear. The sun is nuclear fusion, and the core of our planet is nuclear fission. This is what protects us when there is a solar storm. Nuclear is the fundamental energy of the universe. It is a beautiful, very powerful energy source. And we have a number of nuclear plants coming back, not in Switzerland, but still, as climate change affects Switzerland from all over the world, the fact that nuclear plants are going to be built all over Europe is going to affect Switzerland, and it's also an immense business opportunity for Switzerland to get involved. The solution that we would like to propose is called transmutation. It's a third way between fusion and fission, and now we have transmutation, which is a way to destroy nuclear waste, to extract the last energy that they have, instead of warming up in the deep hole that we're going to make, to be able to extract the heat that they still have useful for us. The principle, and this is why it's in Geneva, is because it uses a particle accelerator. And they have CERN in Geneva, which has created the most powerful particle accelerators in the world, and you have the greatest specialists in the world of particle accelerator. And that particle accelerator basically shines a beam directly onto the long-lived waste. I can, go into details, but this is the basic thing, and destroys them. And that extracts the heat, that instead of this heat going on for a very long time, basically it makes it extract very quickly by destroying them. So it is not an idea that is just on paper. It was demonstrated, as you can see here, it was demonstrated in a real experiment that when you turn off the particle accelerator, basically the whole fission reaction stops within 2 milliseconds. So it's almost like turning the lights off. And that creates intrinsic safety. So what you have is an inherently dangerous system that becomes intrinsically safe. And you have such a system in your life that you use probably almost every day. An inherently dangerous technology that you use every day because it's so safe, it's intrinsically safe. It's called the elevator. We want to be the elevator of nuclear waste. We want to make nuclear waste safe and then be able to bury it, because we're going to need to bury it somewhere. We need to bury it, but it will be for shorter time and within a safer environment. Indeed, once we extract that heat from this nuclear waste, we might as well use it, because heat is the problem of the energy transition, not electricity. 50% of the end use of energy is heat, not electricity. So if those nuclear wastes still have energy in them and we can extract it in a safe way, we might as well use that heat. And if it's intrinsically safe, like elevators, we might be able to put the system close to urban centers or to industrial centers. It appears crazy today, but if the technology is proven safe, it might be possible. The waste that we would take from the existing stockpile would be reduced by 100 times in volume. This is the case for American market, which doesn't reprocess their spent raw, their used fuel. So it's a very special case. It's the most extreme case, but some other countries do the same. It's less true in Europe, but 100 times. But also, we would reduce the radioactivity of that waste by 1,000 times. So you go from 300,000 years to 500 years. And you can see at the bottom of that slide, 5,000 years separates us from the pyramid to the Eiffel Tower. And you can compare to 300,000 years. 500 years is still long, but it's a bottle of water that you throw in the ocean will last for 500 years. Or a cigarette butt that you throw away will last for 500 years. We are not careful enough about our ocean. It turns out that nuclear waste is probably the best managed waste we have, because I was in plastic waste and it's terrible. We have to be more careful about our waste, and nuclear waste is showing the way. In fact, studies have shown that this could be a truly impactful technology. This is the case of Germany, and you can see the blue arrow. It reduces the stockpile of plutonium that is in Germany significantly over a number of decades. But it's not 300,000 years. It's just a number of decades. And so we hope to be able to implement that worldwide. And why we're doing it from Switzerland is because it was first conceived in Los Alamos in America, but improved and demonstrated at CERN in Geneva, and also at the Paul Scherrer Institute. The first experiment at CERN under the leadership of Nobel laureate Carlo Rubbia, who improved on the Los Alamos project, was that it does have a gain in energy. So if we don't want to pay for the electricity to destroy the waste, we could actually have the waste produce electricity enough to destroy itself. The second experiment is they demonstrated the destruction of nuclear waste, especially difficult one to get rid of in general, technetium and iodine. And then the third is the demonstration at the Paul Scherrer Institute in Willigen, which demonstrated the long-lasting operation of what we call the target, which connects the particle accelerator to the cauldron where you have the nuclear waste. Today, we have created a movement more than a business. We have established collaboration with a number of international prestigious institutions, such as Argonne National Lab in the United States, for the retreatment, for the treatment of the waste and the separation of the waste from what is not so toxic. We have in France with Alcen, which is one of the most advanced, technologically most advanced robotic company in the nuclear field. We have a partnership in the Czech Republic to do testing using their nuclear reactor. We're probably one of the few, if not the only, nuclear, quote-unquote, nuclear startup that has access to a test reactor, because in Europe, test reactors have been put offline, which has stifled innovation. We have a partnership with EPFL in Lausanne. We have a great partnership with the Paul Scherrer Institute for the cyclotron design and making a new generation of power cyclotron. The Paul Scherrer Institute is the owner of the most powerful cyclotron for the last 30 years worldwide. It's an incredible technology institute. We have Enea in Italy, which is the foremost energy research center for Italy, which does amazing work. We have the University of Waterloo in Canada, which is helping us to develop quantum computing algorithm to do our simulation, our nuclear simulation. And of course, we have a beautiful partnership with CERN, which is encouraging us, helping us, giving us advice, and also when we need it, hopefully we'll be able to use their facilities for some tests. We also have a natural partnership with France, and the proximity of Switzerland, but especially Geneva, to France is precious because France is a world-class country for nuclear in general, but especially nuclear waste. It's probably the most advanced country with Russia for the treatment of nuclear waste. And so we have our first subsidiary is in France, and we think it's going to be a very fruitful natural partnership. What enabled us, what gave us the dare to get into this? Everybody's saying government should be doing this, government should be doing this, but it happens that SpaceX has changed the way we conceive of entrepreneurship for large, complicated projects. We believe that by looking at big projects, we can sort out, we can engage with financial institutions, we can receive advice from experts, we can make partnership in a way that no government institution can do. We have much more freedom, and we can get enough money and go forward and develop the technology, and then the governments can help us and encourage us, which is exactly what happened with SpaceX. In fact, clean tech investment is still lagging compared to where it should be. We should be at 10 times that, because this is the number one problem of our generation, how to do an efficient energy transition. But it's growing, even in Switzerland, and you can see from this slide that it's approaching biotech, which is one of the most important sector of Switzerland. So we have great hope that we're going to be able to find even a lot of money. And I want to finish this speech by telling you how important it is to deal with waste. Usually it's natural not to want to deal with waste, but we love waste. We love waste like a lotus flower loves waste when its roots is in the mud, where you don't want to thread with your bare feet, but it grows into its gorgeous flower at the surface of the water. What happens here in this slide is the effect of the sewage system. We don't remember, but 200 years ago, there were waves of cholera pandemics and typhoid fever because the cities were disastrously dirty. Without sewer, we wouldn't have the urban civilization that we enjoy so much. This slide represents the death of infants before water treatment and sewage. It was a dramatic improvement in our way of life and enabled urban civilization. The same with penicillin. Penicillin was only a reality because of World War II, because we had to deal with it, because we had to get penicillin. Nobody wanted to do it. Nobody thought it was going to be possible. Same with vaccine for the COVID. 30 years of research, and then suddenly you're able to get it within 1 year instead of 15 or 10 that people thought was necessary. So tonight, I say we need to deal with nuclear waste. We cannot leave this to future generation if it's not well managed in a responsible manner. And some countries are doing it very well, but some countries still are struggling with a solution, and Switzerland should rise to help these countries by developing great technologies, great systems, by being a model. And I had a discussion with Nagra, who is going to bury the waste, and it's absolutely amazing the job they're doing. And it's the same in France. but we're here to help. We're here to engage Swiss technology innovation in order to offer the world the possibility of getting rid of nuclear waste and hopefully provide some energy that will help the energy transition forward. So here's our ambition. We would like to go from waste to hope and offer the future a bright, beautiful hope for an energy transition. Thank you very much. I guess there are questions. If there are, I'm happy to answer any question, of course. How do you finance the project? So the first question is, how do you finance the project? We have raised money from angel investors in the US, and then we found a beautiful fund called Union Square Ventures, which has huge success. They were the backer of Twitter and MongoDB and Coinbase, for those who know cryptocurrency, and also AliCorp, which also is a very successful fund in the US. So we've been successful in raising money from the US, and now we're raising more money around the world. Do you load, so I'm sorry, I can't. So do you load thorium into the reactor, turn on the accelerator at 1 gigawatt and the reactors start working, or do you have to wait until uranium-233 accumulates into it? Well, good question for somebody who actually knows what he's talking about. First of all, our accelerator is not going to be 1 gigawatt. Our accelerator is going to be in the 600 to 800 megawatt. And well, that's the thing. You know, we use thorium combined with nuclear waste because thorium doesn't become plutonium and other minor actinides because it's so far removed from plutonium. Therefore, it's great to have this combination of waste and thorium. But we could also do fuel that is almost all waste, and therefore, you know, the transmuter would be there just to transmute pure waste. You said as soon as the accelerator stops, the reaction stops. But then there's still decay heat, which, as we saw in Fukushima, still poses a challenge. You're absolutely right. Decay heat is very important, but the problem at Fukushima was the accumulation of hydrogen. This is why it exploded. Actually, when the core melted, it was almost contained, but the accumulation of hydrogen made it the roof explode and the radioactivity go out. So we don't use water in the reactor. We use liquid metal, and therefore it doesn't produce hydrogen. So yes, we have all kinds of safety for decay heat. You should know that when you're using liquid metal, there is a lot more safety margin than with water. And so we think that this is a problem to be studied, but it's not as much of a problem as with water-cooled reactor. That is a good question. What is our time schedule? What is your time schedule? Our time schedule is, I love this, is you know, as fast as possible, as slow as necessary, we hope to go, of course, very fast. We want to have a first of a kind by 2030. We haven't chosen the place. We're going to study that next year. We have a very hard-working team in Geneva and in Aix-en-Provence. This is a very ambitious project. We have gone much faster than we expected, but as soon as you go into the engineering, design, and details, of course, then we need a lot of financing, and hopefully we'll be able to get that. We believe the world will have to face the nuclear waste problem, and it's too bad not to use that leftover energy in the nuclear waste for heat and maybe electricity down the road. I don't know, but we have to deal with the waste, and therefore we believe the world is going to encourage us to go faster. Why are you not planning to build your test facility in Switzerland, and how can Nuclear Forum help to make it happen? I am not Swiss, so it's very hard for me to talk about Swiss politics. I am extremely respectful of the expression through the vote of the Swiss public. The law says, we cannot build a new reactor in Switzerland. It's not for me to decide. But any test, the Swiss law doesn't forbid tests and research. So, we're happy to be here because we are welcome at the PSI for the accelerator. And we would love to do as much as possible in Switzerland, of course. And we think the framework, the legal framework is fine for us to proceed forward. And then we also have France where we can do things over there. Are we sure CERN will provide accelerator services to clients like Transmutex? CERN's mission being fundamental research, not energy production. Well, of course, we are not asking CERN to do research. We have a partnership, we have a collaboration with CERN, and we would, if we need to test some material, for example, if we need to test the resistance of something, if we need to test a magnet, a superconducting magnets, things that are very similar to CERN, in the spirit of collaboration, it's normal for CERN, and they are happy to do that and to share the result of the fundamental research that has been paid by the European public. So whenever they can do that, they do. They don't go much further, and we're not asking them to do research on nuclear waste or anything like this. Neither do we ask the PSI to do this. We just want to get some material testing and improvement on certain concepts. Same as with PSI, where we do the accelerator work, the target work. We also have some advice about safety over there. So CERN is not going to do research for us. They're going to help us on some aspect. That's the spirit of a collaboration that we pay for. We pay CERN for that collaboration. Your in-house expertise seems to be focused on the particle accelerator aspects. Are you planning any collaboration with any organization with experience in reactor design and construction? Actually, yes, we do. Unfortunately, this is confidential because we're in the middle of some very important negotiation, but we are talking to the leaders in the world for nuclear reactors, and they are very interested. So we are hopeful that we'll be able to have a nuclear reactor. We don't want to design it ourselves because we think some other people are way ahead of us. So we concentrate on what is new software, the cyclotron, the target, the testing, and designing the system as a whole. But the reactor design, we're not going to do ourselves. We're going to license it out. Has your concept been discussed with the safety authorities? And if so, what was the reaction? Well, we're not advanced enough yet, and we don't need... we're not going to do an installation in Switzerland unless the law change or something changes. So right now we're not in any requirements to talk to the safety authorities in Switzerland, but we're happy to talk to anybody. I had a discussion with NAGRA. We have a discussion with all the energy companies here in Switzerland. I discuss with anybody who wants to engage in the dialogue about nuclear waste and nuclear energy in general. Energy in general, I'm happy to discuss. Would your decision to build a test facility in Switzerland change if the government changed the law? We're delighted. We love Switzerland. I love Switzerland. I think it's an amazing place for innovation, for talent, for everything. And I'm very, very grateful to be here and to be able to work here, especially since it's close to France and the synergies are fantastic. Of course, if the government encourages us to do something in Switzerland, I would very happily entertain it, of course. How do your projected cost per tons of spent fuel compare with geological disposal? Well, this is a key question. It depends on the situation of each country. I've shown you America. America has special problems special challenges for the recycling of the waste and storing the waste. In France, they're retreating the waste to a large extent. In Switzerland, they have a very advanced plan for geological storage, and since they are planning that there will be no longer any other nuclear plants, it's quite a finite world, which is easy to deal with. But China is building 15 reactors a year for the next 10 years. And Russia is still building, and India is building, Bangladesh, Argentina. So this is a quite adaptable technology, and we have to study every country, every situation carefully before we can make more of a statement on this. That's it?
Yeah, I think
okay.
This was...
Thank you very much. Thank you for listening, and please send the question at info@transmutex.com, and we'll happy, if we have the time, hopefully we'll have the time to answer them. Thank you very much.
Dear Franklin, thank you very much for coming to our hour tonight.
Thanks.
It was very inspiring. It was a marvelous presentation. I learned a lot. So we bought you some wine.
Really? That's great.
That's for you.
Swiss wine.
Exactly.
Okay, that's great.
From Globus. Thank you very much.
Globus, thank you very much.
We keep our fingers crossed for Transmutex. We hope for the best. But I think you're really on the way to become a cornerstone of nuclear energy in Europe. So, yeah, thanks for joining us tonight.
Okay, thank you. Thank you, Lucas. Thanks.
No, it isn't.
No?
Sorry.
To be careful.
Yeah, exactly. Yeah, dear members of the Swiss Nuclear Forum, dear guests, thanks for joining us tonight. Let me give you one or two words about our next event. On the 9th of March, we are organizing a political battle about landscape protection and energy policy in Switzerland, in German called Landschaftsschutz und Energiewende. Our guests are Professor Michael Ambühl from the Federal Institute of Technology. We have a political battle between Member of Parliament Kurt Fluri, Member of Parliament Christian Imark, and Ursula Schneider-Schüttl. If you want to join us online, the link for the registration is on our website. You will also find Franklin's slides on our website, www.nuclearforum.ch. So that's it. I wish you a wonderful evening, and I hope to see you again at the future event of the Swiss Nuclear Forum. Bye-bye. Have a wonderful night.